I am Pollabjyoti Borua of third semester from Mechanical Engineering Department, Tezpur University. This video is for solving couple of questions of Fluid Mechanics 1 for Sessional Test 2. Now coming up to the question number 1. For a flow in the xy plane, the x component of velocity is given by y equal to ax whole into y minus b, where a equal to a feet inverse into second inverse, b equal to 6 feet and xy are measured in feet. Find a possible y component for steady incompressible flow. It is also valid for unsteady incompressible flow. Why? How many y components are possible? So the solution is here, given x component of velocity, we have to find y component for incompressible flow, or which is valid for steady or unsteady, and how many components are there. So we know the basic equation: del x into rho into u plus del y rho into v plus del z rho into w plus del t rho equal to 0. We have to assume that this flow is incompressible flow flowing in the direction of xy plane. Here we know that del x u plus del y v equal to 0, or del y v equal to del x u equal to ax whole into y minus b, which is given in the equation. So we know the solution is equal to minus a whole into y minus b. Okay. Then the second part of the question is then integrating vxy. With integrate we know the solution minus a into y square by 2 minus b into y plus fx, where fx is any function of x. The basic equation is valid for steady or unsteady flow, where t is not explicit. There are an infinite number of solutions, as we know. Since fx can be any function of x, the simplest is fx equal to 0. Then vxy equal to minus a into y square by 2 minus b into y, and vxy equal to 6y minus y square by 2, which is the required solution. Now moving up to question number 2, we know, consider the velocity field v vector equal to a into x to the power 4 minus 6x square y square equal, which is not equal, this is positive, this is positive, this is positive y to the power 4 I cap plus a 4xy cube minus 4x cube y z cap in the xy plane, where a equal to 0.25 per meter cube second inverse, and the coordinates are measured in meters. Is this a possible incompressible flow field? Calculate the acceleration of a fluid particle at point xy equal to 1. Here given the solution, here we know the velocity field given in the question. We have to find whether flow is incompressible and acceleration of the particle at the point 2, 1. We know the basic equation: del x u plus del y v equal to 0, where the acceleration of the particle dv by dt, we know the formula of the acceleration dv by dt, which is total acceleration of a particle, equal to u into del v del x plus v del v del y plus w del v del z, which is convective acceleration. This part is convective acceleration, plus del v by del t, which is local acceleration, and total summation of this convective acceleration and local acceleration is equal to total acceleration of a particle. Uxy equal to a into x to the power 4 minus 6 x square y square plus y to the power 4. As we know the question is about incompressible flow. So del x u plus del y v equal to 0. Putting the values, we know del x a into x to the power 4 minus 6 x square y square plus y to the power 4 equal to a 4x cube minus 12 xy square, and del y. Now now differentiating with respect to y, then we find del y a into 4xy cube minus 4xy cube equal to minus 4x cube minus 12 xy square. Now moving up to the second part of the solution. Here hence we know the del x u plus del y v equal to 0. For this flow, acceleration in the direction of x, ax equal to u del x u plus v del y u, and which is ax, which is acceleration, equal to a into x to the power 4 minus 6x square y square plus y to the power 4 del x into a x to the power 4 minus 6x square y square plus y to the power 4 plus a into 4xy cube minus 4x cube y into del y into a x to the power 4 minus 6x square y square plus y to the power 4. Then we know the acceleration of the particle in the direction of x. In the direction of x, we have find that for a square x square plus whole into x square plus y square whole to the power cube, ay equal to u del x v plus v del y v, as we know the equation. Then ay equal to a x to the power 4 minus 6 x square y square plus y to the power 4 del x a into 4 xy cube minus 4x cube into y plus a 4xy cube minus 4x cube y into del y into a 4xy cube minus 4x cube y, which is similarly as the ax direction. Then ay equal to 4a square y x square plus y square. Then we know the point is given 2, 1, which is we need to solve it out. Ax equal to 4 into 1 by 4 into 1 meter cube 1 by meter cube second into whole square into 2m into 2m whole square plus 1m whole square to the power cube. Then it is the solution is given that ax equal to 62.5 meter per second square. Then ay equal to 4 into 1 by 4 1 by meter cube second whole square into 1 meter. Then 2m whole square plus 1m whole square whole cube. The m which is given in the question is meter. Then ay equal to 31.3 meter per second square. A equal to, then we know the resultant formula. Then a equal to root over ax square plus ay square. Then we find a equal to 69.9 meter per second square, which is the required acceleration. Then moving up to question number 3, we know the question is an incompressible liquid with negligible viscosity flows steadily through a horizontal pipe. diameter linearly varies from 4 inch to 1 inch over a length of 6 feet. Develop an expression for the acceleration of a fluid particle along the pipe center line. Plot the center line velocity and acceleration versus position along the pipe of the inlet. Center line velocity is 3 feet per second. In this question we need the particle, fluid particle, acceleration of a fluid particle, and then we plot a two graph. One is velocity and distance, and another is acceleration and distance. So the solution is, here is the diagram. The flowing direction, the flow of fluid direction in left to right. The diameter given 4 inch. This is the diameter given 4 inch, and this diameter is given 1 inch, which is varying from one point to another point. 4 inch to 1 meter, 4 inch to 1 inch, 4 inch to 1 inch. Then this is the graphical representation. The direction is x, and this is x direction and this is y direction, and the distance covered by 6 feet. We know the basic equation. For this question we know the basic equation: del t, lower limit is cv, p del v plus integration rho v into dA equal to 0, where the lower limit is cs. Then acceleration of the particle, we know the equation, dv by dt. We know the acceleration formula, dv by dt equal to acceleration, which is total acceleration of a particle. Then we know u into del v by del x plus v into del v by del y plus w into del v by del z, which is convective acceleration, plus del v by del t is local acceleration. The total summation of convective acceleration plus local acceleration is total acceleration of a particle. And we assume that the flow of the liquid is incompressible flow and uniformly flowing, but varying in diameter. Continuity, we know the continuity reduces to sigma s v summation cs v dot a equal to 0, and for the flow rate q equal to va equal to v into pi d square divided by 4, as we know the formula, which a is area, but d equal to di, but we know the formula d equal to di plus d naught by di by L into x, where di and d naught are the inlet and axis diameters, where di and d naught are the inlet and axis diameter, and x is the distance along the pipe of length L. D 0.0 to di, dl equal to d naught. Hence vi into v di square by 4 equal to v into pi whole bracket di plus d naught by di divided by L x into x whole bracket to the power square equal, as we know, v equal to vi, di square divided by di plus d naught minus di L into x whole square equal to vi by 1 plus d naught by di minus 1 by L into x whole square. This term vx equal to vi divided by 1 plus d naught by di minus 1 divided by L into x whole square. As we move to second part of the question, some representative values are v equal to 3 feet per second, v L by 2 equal to 7.68, feet per second, where VL is equal to 48 feet per second. The acceleration is given by, as we know, the acceleration is dv by dt, which is total acceleration of a particle, and equal to u del v del x plus v del v del y plus w del v del z, which is convective acceleration plus del v del t equal to local acceleration, and this total summation is total acceleration of a particle. For this flow, acceleration of a particle in x direction, which is ax, equal to v del x v equal to del x u, maybe ax equal to vi divided by 1 plus d naught by di minus 1 divided by l into x whole square into del x into vi divided by 1 plus d naught by di minus 1 divided by l into x whole square equal to some by if evaluate it, we know the solution 2 into vi square into d naught by di into minus 1 2 into vi square d naught by di minus 1 divided by l into x d naught by di minus 1 divided by l plus 1 whole to the power 5, where we know the acceleration of a particle which is in the x direction is equal to 2 vi square into d naught by di minus 1 divided by l into x into d naught by di minus 1 divided by l plus 1 to the power 5. Some representative values are x, ax, which is in the direction of x, acceleration, which is acceleration equal to 2.25 feet inverse feet per second square. Ax equal to l by 2 equal to 23.6 feet per second square. Ax equal to, for the function of L, equal to 2.30 into 10 to the power 3 feet per second square, which is the required solution, and the acceleration of the particle which is we need to solve in the direction of x. Then we come up to the graphical representation, which is in the direction of positive x-axis direction, which is covered by velocity versus distance and acceleration versus distance. Now the questions are end, which is we required to solve. Thank you.